is going to be about rhombuses. As you can see from the middle of this page of notes, it defines a rhombus in bold print there as an equilateral parallelogram. So one of the things we'll be reviewing here in a moment is at the top of the page, what is a parallelogram and what were the properties we learned last week. But before we get into that about parallelograms, we need to go back and review some simple math from first semester about triangles. So we have three things to review about triangles to find missing angles. This is things you know pretty well, but we're going to make sure you know them very well because you're going to be using them today in rhombuses. So, first thing would be, how do you find the missing angle in a triangle? And the answer is, to find the missing angle in a triangle, you always subtract from 180. Because the total amount of angles in a triangle add up to 180 degrees, no matter what type of triangle it is. So, take 180. Subtract 27, subtract 46, and it turns out here we get an answer of 107 degrees for that angle that looks obtuse. 107. If this is an isosceles triangle, and sorry it wasn't already marked, but if it's an isosceles triangle, not only are the two sides congruent, but also these two base angles are also congruent. So the math is the same to start. All we know how to do to find missing angles is subtract from 180. And we get an answer of 146 degrees, which doesn't make sense at first because that's way too big. How do we have an obtuse angle when there's no obtuse angles in the triangle? And the answer is we don't. We have two missing angles, one here, that total 146 degrees. You divide by 2, and you get 73 degrees, not for just one missing angle, but for both missing angles, because both missing angles are congruent. Lastly, easy, how do you find the missing angle in a right triangle? Subtract from 180. 180 minus 68, and also minus a second number. We don't divide by 2 here. There are not two missing congruent angles. There's only one missing angle over here on the bottom, and here at the top, even though it doesn't have a number there, that angle is 90. So when you subtract 90 and 68 from 180, you get 22 degrees. All these problems are pretty easy, and you probably already knew how to do them. The question is, would you remember to do them in a rhombus when you saw triangles in a rhombus? So we thought it made sense to review first a little bit on which things would go with which. So now getting back to the new notes here. A rhombus is an equilateral parallelogram. What does that mean? Well, parallelograms, you have the left side congruent to the right side, top side congruent to the bottom side, opposite sides are congruent. Also, the opposite sides are parallel, opposite angles are congruent, consecutive angles add to 180. These are properties you did in your IXLs before spring break on the 2 e-learning days. A rhombus is the same thing, but it's equilateral. So the first and most important property is that equilateral, all sides are equal. So yes, the left side's equal to the right, and also equal to the top, and also equal to the bottom. All 4 sides are equal, not just the left and right, not just the top and bottom. All of them are the same. What math does that mean you have to do here? Well, that means if it asks you to find a side, like find AD, do I use 12? Do I use 51? Oh, look at that box, there's a 90 in the middle. Well, wait a second here. All sides are the same. We're trying to find a side, the left side AD. That means it's just equal to the top, 12. There's no math to do. There's no adding together. There's no subtracting from 180. We're finding a missing side. If we have algebra on the missing sides, like here and here, you set those two things equal because all sides are equal. That's what equilateral means. If you solve this out, it solves out to be x is 24. Here it asks to find CD, so you're going to plug things back in. CD is this missing side here on the bottom right, but because it's equilateral, that side on the bottom right is equal to the sides on the left and the top and the bottom and everything. So it doesn't matter where you plug it back in. Wherever you plug 24 back into, you would get the same answer, in this case of 179. Careful, not 179 degrees, 179 inches, centimeters. It's not listed which one. Doesn't matter. The answer is just 179. So similar to other problems you've done, you'll have to solve for x occasionally by setting two things equal and plugging back in. There are two other properties of a rhombus you'll need to know. In parallelograms, we had the diagonals bisect each other. That property also works in rhombuses as well. I'm not going to draw in the markings on the inside, but yes, those diagonal markings would be the same. The bottom left is equal to the top right. The top left is equal to the bottom right. But more interestingly is a couple of other properties. In a parallelogram here on the top, you had two obtuse angles and two acute angles, but not here in a rhombus. In a rhombus, they intersect perfectly at a 90-degree angle in all four spots. The best way to phrase that would be diagonals perpendicular. The word perpendicular, which you haven't used consistently since December, means a 90-degree angle where two things intersect each other at. So there'll be something having to do with 90 degrees, similar to the previous page where we did triangles with 90-degree angles. The last property here is that in a parallelogram, these numbers were often different in a corner. So the whole angle there looks acute on the top picture. Maybe it's 60 or 70 degrees. But what was interesting is the two pieces, one was bigger than the other. They had some alternate interior angles involved with them, but the two angles were different. Here in a rhombus, the diagonals not only bisect each other, but also bisect the angles. That means this angle is equal to the other angle here. And because opposite angles are congruent, that means the top right also has the same two parts. All four of those little acute angles are the same. Similarly, here on the top left of the rhombus, those two angles are the same, equal to the two little angles on the bottom right of the rhombus. So we have a bunch of different angles in a rhombus. We have 90 degrees at the center. We have obtuse angles cut into equal pieces, four total little pieces the same. And we have the other angles cut into four little acute angles where all of them are the same. So what are you going to have to do today in your IXL? And the answer is, first, like the bottom of this page, you'll have to set sides equal, or just know that they're the same. Secondly, you'll have to solve problems with rhombuses where there's one diagonal. So when there's one diagonal, what does this look like? Well, what it looks like is a triangle. And since it's a rhombus, the two sides are the same. So, this looks like our first page we did when we did isosceles triangles. Like the first page. Subtract from 180. 68 degrees, some people might think is the answer, but remember, the whole idea is that these two angle pieces here and here are the same. So divide by 2, and you get 34. Careful, not only is 34 the answer for both those marked angles, we're trying to find TVU. Angle TVU is also 34 degrees. If you have algebra in the problem, take a look at this problem over here. It's the exact same type of problem, except there's some algebra there. I'm going to do the same math to start. 180 minus 66 gives you 114. You're going to divide that angle by 2, and you get 57. So that means this angle's 57, this angle's 57, this angle's 57, this angle's 57. The other one on the other side would have to be 66, because opposite angles are equal. And then angle DFE is this angle right here. So you'll just set this equal to 57. Solve out the algebra, add 78 to both sides. Divide by 3, divide by 3. Comes out to be 45. So the second set of problems we're going to be dealing with are looking just like this, where there's one diagonal in the rhombus. And then lastly, the final type of problems you'll see in this IXL is when there's two diagonals in a rhombus. This turns out to be even easier, similar to the first page of our notes. So you can see here, we're trying to find the missing angle. How do we find the missing angle YXZ? Well, this is 33, this is 33, this is 33, this is 33. Like our notes on rhombuses, all the angles on the inside have to be 90. And like our first page of notes, if we're trying to find the missing angle in a triangle, subtract both the 33 and the 90 from 180, and we get 57. This angle here is 57. This angle here is 57. All the missing angles are 57. that we were trying to find. In this case, yxz is 57. Same idea if there's an algebra problem. Subtract from 180. Get the missing number, but wait, if there's algebra, which you're going to see in the IXL levels as you get to a score of like 50 or 60 or 70, you set the algebra equal to your answer. Don't just type in your answer after subtracting from 180, and whoops, I made a mistake. 180 minus 29 minus 90. There's a 90-degree angle in the middle there. Gives us a missing angle of 61 in all of these spots here, including JGK, what we're trying to find. Set the algebra equal to that number, not plug it back in, not just type that number in, but set algebra equal and solve it out. In this case, you get B is 76. That concludes our lesson here today. You're going to have 3 types of problems on your IXL. The first will be like this when there's 2 diagonals in a rhombus. If there is, subtract from 180 minus the angle in the problem, minus 90. That'll give you your answer. And like the problem on the right, if needs be, set up an algebra problem. Second type of problem in your IXL will look like this, where there's 1 diagonal in the rhombus. Subtract from 180, divide by 2 because it's an isosceles triangle. And if needs be, set up an algebra problem. And lastly, the easiest type of problems, like the bottom of this page of notes on a rhombus, where like on the bottom in blue, set 2 sides equal. Just set them equal. Only if it asks you to plug it back in would you have to plug it back in. Good luck on your IXL. Send me or your teachers any questions if you have any problems solving your IXL out. And good luck on this e-learning day. Hope everything's going well.